All right, before we even look at these pictures and try to figure out the answer to this question, let's talk about what it means to have a factor of vertical stretch or compression. So over here, let's think about this. Factors of compression / stretch. So let me talk about first factors of compression. So if I had a graph, and you can think about a parabola as the easiest way to think about it, but it can be any sort of graph, and I am compressing it vertically. That means that I'm taking my hands from the top and I'm kind of pushing down on my function. And so that would look something like this. And this might be something like y equals 1/4 x squared. And my factor of compression would be the 1/4. And if I had something like maybe 1/16 x squared, you can imagine that it would be even more smushed. And so that's what I mean by factors. So this would be y equals 1/16 x squared. So you'd be compressing this blue one by a factor of 1/16. You'd be compressing this red parabola by a factor of 1/4. And obviously the number tells you how compressed it is or how not so smushed it is. And the same thing holds true in terms of vertical stretch. So you can imagine here, if I have a 3x squared, it'd look like that. But if I had maybe a 25x squared, it would look like that. Really, really, really narrow. Okay, so that's what I mean by a factor of compression or stretch. So to identify what that factor is, we just look at it. And so it's really easy when it's on the outside. It's just 3. That's it. This parabola has been stretched by a factor of 3. And so we want to say that perfectly. We want to say that this parabola right here has been stretched vertically by a factor of 3. And don't overthink this. That just came from that number 3 there. And then same thing here, it's not too hard at all. We're going to say that this blue equation here has been, in this case, because it's a fraction, we can say it has been compressed vertically by a factor of 1/2. And that's it. So not too hard. You basically say if it's been vertically or horizontally, and then you would say if it's compressed or it is stretched, and then you would give the number. Now, it does get harder when it comes to the number being inside. Okay, so in a situation like this, notice how the 2 is on the inside. See how my A is on the inside? And this would be a compression horizontally, and then you'd have to take the reciprocal of that number. So for that green equation right there, I'm going to call this problem number 1. That has been compressed horizontally by a factor of, well, I have to take whatever that number is right there, 2, and I have to take the reciprocal of it. So I'd say 1/2. And that's it for that one. Let's go ahead and try number 2 here. Okay, for number 2, we actually do have a fraction. You can see 0.5, which is the same thing as 1/2. And so therefore, since A is a fraction, it has been stretched horizontally. By a factor of, and now I'm going to have to take that 1/2, and it wants me to take the reciprocal of it, so I'm going to say 2. So folks, there's a way to memorize this, I think. The first is, if you're going to answer with the word compressed, you better have a fraction as your answer. Okay, let's look at the previous slide here. See how this says compressed and you're answering with the fraction? So that's one way to memorize it. If it says stretched, you should have an answer that is a number that's not a fraction. You can see that here as well. I say stretched and you said 3. The other way to memorize it is if we're talking about a number inside the parentheses, then that's going to be a horizontal answer, and it's going to be the reciprocal answer.